All right, I think we should start. Brian, you are way too loud. Yeah, well, Maven, it's an emotional topic, I guess. Okay. We're going to talk about applying Dr. Kahneman's insight to improve developer practices and efficiency. We're obviously going to talk about who Professor Kahneman is and everything in a second. My name is Baruch Sadogursky. I'm at J. Baruch, a developer productivity advocate with Gradle. My career path, I started as a developer, experienced all the productivity challenges, then went to DevOps, experienced more productivity challenges, and now came full circle to the development productivity engineering part with Gradle. They wrote a couple of books, DevOps tools for Java developers and Liquid Software. They don't necessarily, not necessarily related to developer productivity, but you know what, everything is. So they kind of are. Feel free to check them out. The most important slide of this talk is this one. If you go to speaking.jbaruch, you will find there the slides, the video, and all the links for all the research, for all the papers, for everything that we are going to talk about. They're already all there to make sure that this is easy accessible. On the bottom of every slide, you will find exactly the same link, so you don't forget. DPE is the hashtag for Developer Productivity Engineering, and JBaruch is my whatever today's name X handle. Follow me for controversial takes and stupid jokes and what's not. All right, Daniel Kahneman, Professor Daniel Kahneman, unfortunately passed just like less than a month ago, and he is a legend, a Nobel Prize winner for basically for Nobel Prize in economics. It has nothing to do with economics. His research is in behavioral science. Now, if you ever took economics basic 101 course, economics theory starts with people will behave in their interest. They will buy more stuff when it's cheaper. They will buy less stuff when it is expensive. Supply, demand, all very reasonable and rational. All the modern economic theory is based on this assumption, and it actually works, right? So if there is a sale for something that we want, we will buy it more. And when the price goes up, we will buy it less. So it all makes sense until it doesn't. And a professor in behavioral science won a Nobel Prize in economics by proving that people are irrational and not doing what the entire economy theory is based upon. This is fascinating, and obviously mad huge respect for Daniel Kahneman. Now, if you want to learn more about his research, there is one book that you need to read, and this is this. It's called Thinking Fast and Slow. And I'm going to kind of make a very short overview of what this book is about in this talk, because we are going to apply the same principles for developer productivity, but it's definitely worth reading in its entirety. So here is what Professor Kahneman is talking about. A bat and a ball cost $1.10 in total. A bat costs $1 more than a ball. How much the ball cost? Fast.
I know that.
You want to say $1? You want to say $1. You really want to say $1. But the total cost is $1.20. If you want to get to the real answer, the 1 and 10 cents, it's actually should be 95. Right? So why? What's going on? Why you wanted to say $1, although it's a very simple mathematical exercise? Of course that if you think about it for a second, you know that $1 is the wrong answer. But you really, really want to say it really, really fast. Hey, I know the answer, of course, but you know what, not really. Because what Professor Kahneman teaches us, that we have two systems in our brain. One that is imaginally called system 1 is in charge for, it's very, very fast. It's very intuitive. It's automatic. It's emotional. And it's very cheap and very eager to provide us an answer. This is exactly what happened when we had with $1 in mind, pops up $1 in mind. This is our system 1. It's intuitive. We have $1.10 and then minus $1.10. Very intuitive and very cheap and eager to give us the answer. The other system, called system 2, is very slow, analytical, controlled, logical, but also very expensive and lazy. When I told you that $1 is not the correct answer, and you're like, okay, now we need to do the math. Now the total is $1.10, and if it's $1 cheaper, it should be actually 95, all this stuff. This, you made an effort to engage your system 2. It took much longer to calculate the answer, not the longest time, but at least a couple of seconds. So it's slow. You made the algorithm, you went through this simple mathematical algorithm to calculate it. It's controlled, you forced yourself to do it, and it was obviously much slower and took much more effort. Now, how this relates to software development? Which of two systems you use when you write code?
System 2.
No, okay, before that. Sorry, I jumped the gun. Another example of experiments of Dr. Kahneman. Remember the following numbers: 3, 4, 6, 8, 7. There is a quiz after that, as you might imagine. So make an effort. 5, 6, 8, 2, 0. 7, 6, 3, 7, 8. 9, 0, 8, 2, 4. You remember? You should. I will ask. There is a quiz. Cheaters take pictures with their phones. 1, 1, 2, 4, 7. No, seriously, make an effort. Try to remember at least, you know what, 2 of them. Okay. Now, I need you to say the color of the word that you will see on the screen. And do it really fast, like really fast, immediately.
Red. Yellow. Orange. Red. Blue. Green.
Yevgeny here, that shouted red.
Yeah.
That was the authentic answer. Right? And that's a great exercise showing you that when you are making an effort to do something, it's much harder to engage your system to do something else. He really tried to remember the numbers. Yes. How do I know? Because he said red in the first test. All of you are slackers and you didn't engage your system too hard enough to actually be distracted by the difference between the text and the color. If you were trying to remember the numbers, as Evgeny here did, you would shout red as he did. He should be proud of making this mistake. Yeah, no, but I mean, it's a silly exercise, obviously, but you get my point, right? When you really engage your system 2 on something, you actually have much harder time to engage it on something else. And that's because you have mental fuel. Now, mental fuel is obviously not a real term. But this is an easy way to think about it. And if you want a hard way to think about it, welcome to Attention and Capacity Limits in Perception, a Cellular Metabolism Account. This is a very, very scientific paper. And you can say right now, because it has tons of those little tiny numbers here, that makes it very, very scientific, right? All those. And it's full of this stuff, like pages after pages of this stuff. Now, I obviously have no idea what any of that means. And what do we do when we don't understand scientific stuff? What do we do? How do we make sense of that?
Simplify. ChatGPT.
Thank you, Evgeny. ChatGPT. Right, so explain the paper, Attention, Capacity, Limits, and Perception, and Cellular Metabolism Account to me, Barney style, in one paragraph or less. Here's, you know what Barney style is? The Americans probably know. The other is, so, Victor. Yeah, okay. Right, so Barney is a small dinosaur, children toy, huge dinosaur. It's huge dinosaur, thank you. Yeah, it's dinosaur, it cannot be small by definition. It's huge dinosaur. It's a children's toy. There also was a TV show in which Barney explained concepts like, not that, but others, to children, Barney style. And it became like a thing, and it's basically said like, explain to me like I'm 5 years old. So that's that. So Barney style. Imagine your brain is like a smartphone battery that drains as you use apps. The paper said that our brain has fixed amount of energy for tasks, like smartphone battery has limited juice. When you do something that needs a lot of focus, like remembering the numbers that none of you did except of Evgeny, it's like running a power-hungry app. And then it uses more of your brain energy. And like closing the apps to save battery, your brain tries to save energy by paying less attention to less important stuff. We'll get to how we have no idea what really important is in a second. Okay, so basically, yes, attention and capacity limits, and that basically says you have mental fuel. Smart stuff, again, I have no idea, billionaires and Oxy, never mind. Cellular metabolism as mental fuel. This is exactly what we have. And it's a finite energy supply. And what they say is exactly what Professor Kahneman found out by his sociological research in physical stuff. Like in chemistry in our brain, they call it high load mode and low mode. This is exactly your system 2 and system 1, just in reverse order. The high load is the system 2. So this is pretty awesome to find a proof of what we observe in people's behavior in actual chemistry in brain. This is very, very exciting. Getting back to that, which system do we use for coding? We already answered that. That would be your system 2. Analytical, controlled, logical. This is what we need to write code. And this is pretty awesome, right? This is software engineering. Now, another concept that is very familiar to you, and it's also explained by scientists, is the flow, right? So this is, and I need to read because otherwise I will get, Mihai Csikszentmihalyi. This is the guy that came up with the idea of flow and with the term. So you all know what it means. Flow is the state of effortless concentration so deep that people lose their sense of time, themselves, and their problems while they're working. Who experienced a state of flow when writing code? At least once. Everybody, of course. Makes sense. Did we like it? Hell yes. Were we productive in it? Hell yes. Did I forget to eat? Maybe. Now, the reason why it's so easy for us to do very hard cognitive problems where we are in the flow is because it makes it effortless. Now, this is an exception. Usually, attention control is very expensive. Where you are not in the flow, you will constantly get distracted. And of course, your productivity suffers. Gloria Marx, professor, spent 25 years in research of attention, human attention, which of course has everything to do with what we're talking about. Just recently, last year, she released a book that summarizes all her research called Attention Span. Again, highly recommended. Now, this book talks about how good are we with attention. Spoiler, we're not. Average person checks their email 77 times a day. That's average. I check it usually twice than that, so some of you might check it only 40 times a day, which is still a lot. Our attention span has divided to about 47 seconds on any screen. 47 seconds. We do something, less than a minute, and then we're urged to do something else. The most important and the most terrifying is this. It takes 25 minutes to return focus to task after interruption. You have a slow build that runs, your Maven build runs 12 minutes. Brian is not here. 12 minutes. For how long are you distracted? For 12 minutes? When you try to multitask and read your emails? No, 25. If you try to multitask and to read your emails while your build is running, I can tell you how long your build is. Your build is 25 minutes. And I don't care what the summary in the end of the build will say. It is 25 minutes. Because you will wait for it 25 minutes because you will be distracted for the next 25 minutes. Time for another. Okay, I shamed you enough with the numbers. Now you do pay attention? I hope so. Okay, tell me what's wrong with this code. No closing bracket. No closing bracket? Really? Where?
Discount is in percent, not decimal.
Discount is in?
0.15. Oh, I'm sorry.
No, we divided by 100.
I didn't write it, that's the problem.
You didn't. If you wrote it, it would be better?
Yeah.
For sure. No, there is a room for improvement, no doubt.
Discount is 0. Discount is 0.
The
Discount is 0.
discount? No, discount is 15. I mean, treasure. Indent? Formatting, you mean? No, it's okay. Kind of, sort of, except of the last line there.
Just like turning thing.
Oh, yeah, no, it prints it. Yeah, it prints it. It's fair enough. Evgeny is asking ChatGPT. Fair enough. It's a minor. It's not like something very, but it's still.
Precedence of operators. Price, that discount divided by tau to the high.
No, that's fine. It works. It's yeah. Yeah. Go ahead.
Is there going to be loss of precision somewhere?
Almost. That's where we're starting to get close.
Data types.
Yeah. Go ahead.
I might be wrong here.
Your
but
formula is
100
incorrect.
An integer discount should be. Oh, never mind. Oh, yeah, that's going to return an integer, isn't it?
Divide by integer, you get 0.
Even though it's,
Yeah, do we
even
have to
though
put
it's
D
defined as
after
double,
100?
on the right side.
Final price should be price minus price multiply discount.
Yeah, that's.
Yeah, that's exactly what it does.
Put a,
Yep.
Wait, but
Yeah.
shouldn't, I don't know, an implementation of floating point that is more accurate be used because it's money?
That's there. Anyone like even more banal observation? Like rounding, something. But yeah, basically never use double for any monetary calculations, right? That's generally very good advice. But at least round it up to 2 decimal points, because otherwise you will get some very interesting bullshit here when the numbers are not 115, basically. Right? No, but yeah, good effort, good effort. Okay, I appreciate it. Okay, how many triangles? There is a point for that. We're not just having fun. There is a point.
10.
18.
Yeah,
10. 12.
between 1 and 20. Yeah.
13. 16.
It's more than 20.
15. Getting there. 5. You said it's over 20.
oh no, like if you start from the.
Yeah. Yeah. Okay, 18. 18. 18. Who said 18? Good job. Okay, let's get to calculate numbers. How about that?
No, explain it.
Just count 18? Yeah, there is 18. We can count like, yeah. You know what? I should do animation that counts them, but for next time. Yeah, no, but there are 18. Let's spot a bug right here.
In main, you're passing integers instead of doubles.
Nope.
Minus. It's not tax.
No.
It's tax plus.
Yep.
So it's wrong.
Yep.
The name of the method incorrect.
Yep.
Change the method name.
Less than amount. Waste time to divide by a total amount.
You're basically actually be like 1
Yep. But you didn't get you slacked on the triangles. This is why you got this one. Yeah. No, this is absolutely wrong. This is 500 instead of 5. This is so obvious. And this is much easier than the previous one. And you didn't get it because context switch. You started to look at the code. By the end of this one, you kind of got in the zone. Yeah, okay, we're doing Java now. You started with, oh, you shouldn't do that. And yeah, you got it. You got in the zone. And then you started to count stupid triangles. Like, yeah, this is you reading emails while your code is building. And then, I mean, seriously, Fox, this is like 100 times 5. That's not the tax you want to pay. Even in southern, like Northern Europe or something, that's not the tax you want to pay. And I mean, none of you spotted it for the longest time because context switch. Right? That was pretty amazing example. And this is you writing code every day after interruptions. The problem is you deplete your fuel by context switching. And you just saw a very clear example of that. And you are not in flow because of context switching. And you remember, flow is effortless, not flow is effortful. So it's a lose-lose. You need more fuel, but you have less fuel. More research papers. Characterizing and predicting mental fatigue during programming tasks. Now, this is mind-blowing. You're going to really I'm going to blow your mind now. Developers are cutting corners on quality when they are tired. No. Right? Wow. There is a research about that. Now, you might say, okay, so yes, we are getting tired, we are not as good, and of course, we just spoke about how context switch actually makes us tired faster. So what's the problem in that? We're going to take a nap. You are tired and you stop, but you don't. We don't know where to quit. And this is Professor Kahneman once again from Thinking Fast and Slow. Parole judges issued fewer paroles when tired and or hungry. Because granting parole requires system 2, and the judges didn't realize they had switched to system 1. Now, obviously, they didn't do it on purpose, right? They want to make as good decisions as they can. They are not trying to do slack job. So it wasn't on purpose. And obviously, they didn't realize it because when they would realize it, they would stop it, and they didn't. It's just before lunch, they switched to system 1, and system 1 is deny parole, like the default setting, right? 4 p.m., they're tired, they switch to system 1, and system 1 is deny parole. Now, if judges do that, we do that as well. And then we switch to automatic emotional and kind of a knee-jerk reaction in our code instead of doing the slow, analytical, and controlled. What it produces is OK code. We still know how to do our programming tasks, even when we are tired. It just won't be the best code that you produce. Now, the problem is that you don't realize it, exactly like judges. The code will be not terrible, but definitely not great. And the problem is that, well, you know what, I'll ask you. Which sucks less, bad code or OK code? Bad code sucks less, because bad code can be identified and fixed. OK code flies under the radar. It looks OK to us because we are tired. It looks OK to the PR reviewer because, not because, maybe they are tired, but also because context switching, because reviewing our code is not what they want to do with their system too. The look good to me comment that approved 90% of the PRs, this is your system 1 code review. And this is absolutely natural. This is what we were going to do. And then it looks OK for the pipelines, because whoever wrote them was hungry or tired. And they didn't implement all the wonderful checks they could have. The next thing you know, you have an OK product, which is OK, but it's not great. What do you say? 90% of the software is OK, but not great? Right? Am I on the money? 80, 90? Definitely much more than half of the software that we deal on a daily basis is OK. And that's exactly because of that. So what should we do? The answer is we need to invest in fuel-saving techniques. The idea is we need to run on system 2 all day. And then it's 6 o'clock and you're out of juice, but you're also out of like day, so you can go and rest and use your System 1 to watch your TV shows, play whatever, Candy Crush, or do other things that you do on System 1, which is completely fine. There is nothing wrong with that. It's just like you should write creative code when you're on it. IntelliJ idea, quit unexpectedly. Speaking about interruptions and what's not. Okay, ignore. Okay. What can we do to save fuel? There are different aspects of that. For example, time management strategies. Time blocking, no meetings, I'm writing code, I want to be in the zone. Right, and Google Calendar has focus time, and I bet others as well use it. Manage your time to external parties by saying not like, I don't have a meeting in this slot, but I'm busy except of those times that I allocated for the meetings by thinking about it, right? For most of us, the calendar looks like it's all meetings and I will work in between. No, do the other way around. Fill it with focus time and then allocate time for meetings when you want to do them and when you're ready to switch from work. Pomodoro technique is also time management, which allows us to make sure that we have those blocks of 25 minutes to do tasks uninterrupted. Task batching, allocate similar tasks together. Don't do code, count triangles, do code. Do all the code together and count triangles with checking your emails and sitting during sittings and boring meetings. This is fine. This is time batching. Mindfulness and cognitive practices. Yay, meditation! Did you hear about meditation in a conference, technical conference like DevNexus? You should. It is important. I'm not a meditation guru. I'm not going to teach you how to do it. But you need a way to refuel your system to fuel during the day, especially when you feel that you are tired. There are ways to do that. For example, reflective practices. You can train yourself to spot the fallback from system 2 to system 1. You can teach yourself to recognize when you start writing OK code instead of great code. And it just takes practice and attention to see that. Single tasking, that the opposite of multitasking and context switching. Don't try to lace your shoes and finding your keys in the same time because you won't succeed. You know that you won't succeed. You will still try to do that. Stop it. Make sure that you pay attention, that you don't try to well, there is exception, obviously, for women who can multitask.
Are you sure?
I'm not sure, but it's a good joke to make. Yeah, it's a joke. No one can. Don't multitask, really, you can't. You will, at best, you will do both things badly, at best. Interruption management, workspace, stuff like workspace organization, no open space, no cubicles, yes, offices, all this kind of stuff. Notification management on your phone, on your laptop, on your watches. Turn everything off except of the time when you want to get it. Basically, don't call us, we will call you, works great for all the notifications. You check your email on your terms and not when the email comes. The idea of email is being asynchronous communication, and that means that you don't need to look at it at the second it arrives. Prioritization techniques, obviously, that's exactly how it sounds. Physical and mental well-being, physical exercise. Victor, I want to hear go to gym. Go to gym. Thank you. Go to gym. It's his motto, like he's big on.
Hashtag go to gym.
Thank you. Hashtag go to gym. Go to gym. Breaks and downtime important again on your schedule, not when you are waiting for build, because then every build is 25 minutes break. Don't do that. And developer productivity engineering, Gradle pays me for being here, so I'm going to mention something that is very related to what we spoke about, but also very related to Gradle. What is developer productivity engineering? Faster feedback. That's about getting feedback as fast as possible. Why? Because less context switching. If our build is 2 minutes and not 25, as we learned, is much, well, we do less context switching, obviously. What was the second one? Eliminate toil for developers. Toil drains mental fuel. When we have to deal with stuff that we really don't want to deal and don't have to, it will make us mentally fatigued much faster. Collaborate through effective tooling. We want to be able to do meaningful work with others without disrupting their flow and getting them to context switch. Stuff like prioritize automation and eliminate bottlenecks. People from DevOps, this is right out of DevOps, should recognize that. But how about doing that for your development and not only for your production? Did you think about that? Probably didn't. You should. Embrace rigorous observability and proactive improvement. Another very DevOpsy tenet. Observability for production. We have great observability for production. Observability for your development tools. How many of you work in an organization that measure local build times for developers? Yeah, me and Jeremy, we're both in Gradle. Yep, okay. but yeah, you see the point? And you really should, because this is how you know if the developers in your organization have 25-minute builds, which is everything that is less than more than a couple of minutes. Exactly. Outcomes over output. Just sheer output overwhelms our system too. How do you like going through a build log to find what went wrong, especially with dash debug, for example? Is exhausting. And it's exhausting for our mental fuel. This is what's exhausting about it. If you can use tools that take only what really matters from the tons of output that we have in everything we do, we will save a lot of mental fuel. All this requires organizational mindset. A lot of that cannot be achieved by you deciding that since starting tomorrow, you are going to observe everybody's local build times. You cannot do it. It requires organizational mindset, and the real forward-looking organizations take this very seriously on organizational level. And I really suggest that everybody do. And I want to talk about one of them for the last 5 minutes that we have. We have 2, but we'll make it 5. So less than 25. Let's talk about feedback efficiency for fostering faster feedback. We have an expectation of what feedback looks like. IDE, sub-seconds. We type something in IntelliJ and or whatever VS Code, whatever your thing is, it highlights it red immediately. Sub-second feedback. Build, you expect it to be very fast. You sit there and you wait for it. CI, you already care less. You usually won't wait for CI to finish. You will do something else. And production, feedback from production is pretty important, but you will get it when you get it. So there is a pattern here. It's reverse dependency on distance from developers. The more we go away, like we go right from the developers, the slower we expect the feedback to be, which makes sense. There is one exception. In the real world, the build time is usually not following this trend. The build is much slower than you want it to be. Now, there are 2 types of feedback. You have your asynchronous feedback, and synchronous. Asynchronous is your CI/CD. You don't wait for it, but the results, if your CI failed and you need to switch back to it, is very distracting because you do context switch that you so it's not fun. Synchronous, for example, build, we will wait for it while we are in the flow because it's the same process, but we will be really pissed off when it's slow. We do the context switch, hello, 25 minutes context switch, right? Now, the cut between synchronous and asynchronous is right there in the commit time. You won't wait for your IDE or your build, you will wait, but you won't wait for your CI/CD and your production feedback, which is fine. Now, faster feedback, this tenet that we start, it saves mental fuel. Because speeding up local build minimizes context switch. And then less context switch saves mental fuel, and then you run on system 2 all day. So this is a very simple technique. We can extend your fuel for system 2. And how can we engineer less context switches? By measuring local build times, by avoiding building and testing what didn't change, by speeding up what cannot be avoided, and by fight those flaky tests that will kill our build even when it's nothing wrong, right? So, and there is one more. Watch your build for degradations, right? Because it usually gets slower as time passes. Now, a lot of that you can have today for free. You can run your builds in parallel using the power of your machine. And if you go, when you go to Gradle booth downstairs to get those awesome t-shirts, you can also see a demo of how one line of code, which basically says, use all my cores for testing, expedites your local build 12-fold, from 2 minutes to 6 seconds. One line in the build that says, use all the cores on my machine. Local caching. This is about not building what you don't have to build. Your colleague, you build something, you didn't change it. Even if you're unclean build, it shouldn't be built again. It will speed up your build, save your mental fuel. Remote caching. Your colleague built a module. Instead of you building it, you can use their caches and then skip it altogether. There's a small asterisk over there, which means the remote caching is free, but you will have to set up the remote node that will have the caching data so everybody can pull to it and push from it. It's a little bit of work, not terrible. Build scans. Remember the outcomes over outputs? This is that. When you use build scan, you can get the essence of your build instead of going through each and every line. And this is also collaborate through effective tooling. Everything in a build cache is shareable, so you can express something to your colleagues in a meaningful way. Hey, this line on code break the build. Well, I know it because this is the link, so take a look. Right, so all this stuff is free. You can also win prizes for free when you do something that's called the speed challenge, which speed up your build and you win prizes. Now, what your company should pay for? First of all the books. You go to speaking.jbaruch, you go to the page dedicated for this talk. It will have links to all the books. My books, I get royalties. The rest of the books, I don't. Buy Thinking Fast and Slow, buy Attention Span, great books. Top development hardware. The exercise of speeding up the build 12-fold is achievable on modern hardware, obviously. If you have older machine, the gains won't be so significant. Your boss really should buy you the top hardware. This is how they save your mental fuel and let you write your best software. The velocity that does everything that we spoke about, and the demo is in the Gradle booth. And that's all. Speaking.jbaruch have everything. If you scan, you get to the same page, basically. And then you can take the speed challenge, win prizes, and see how faster your build can be. And obviously, you can read the DP handbook, which is also on the show notes page. And you can watch the DP Summit videos, which are great and talk about this and more. We unfortunately didn't have the opportunity to invite Professor Kahneman. And unfortunately, now it's too late. But we have other pretty amazing stuff over there. So with that, thank you very much. @jbaruch on Twitter if you want to argue or count triangles with me. Hashtag DevOps when you praise this. Why DevOps? I don't know, DevNexus. I was too tired running on System 1. Speaking of @jbaruch, this is where you find everything. And with that, thank you very much. One more thing, free booze. Gradle is hosting happy hour that starts in 15 minutes in the beer house right around the corner. I have the thingy that you need to scan to register. So if you are up to it, well, in some point we will count triangles over there for sure. I have plenty.
Thank you.
Scan and come to have a drink with us, on us. Three more. Two more. Last one. Oh, he claimed it. Yeah, just scan it. Yeah, of course. Yeah, you just scan it.
Should I scan it and give it?
There is nothing like unique about it. Just scan it.
Oh, okay.
Good talk.
Thank you.
Thank you very much.
Oh, another good book is Deep Work.
Oh yeah. I need to edit. Yeah, for sure. No, he already registered.
Talk about attention is in terms of budgets.
Yeah. No, this is great. I know about this book. I need to edit to this talk, and then it will be 2 hours, which is great. Thank you. All right, we have less than 15 minutes to go and drink, and you didn't turn off my video. Shame on you. Well.